We've been talking about a bunch of work that we've been doing over the past 2.5, getting close to 3 years at this point. Actually, I do need to come back over here because I'm going to be able to forward my slides. In terms of doing assurance of AI systems. We're going to talk about that. What we mean by assurance, it's a huge topic, and I'm going to be talking to you guys about it, a sort of very narrow slice of it, right? Yeah. Can you guys hear me?
Yeah.
All right, cool. So what we're really all about is getting at all of the different types of risks that you are tacitly adopting when you put one of these types of systems into production, right? And as I said, even then, scoping it that way, you're talking about a huge area. And I'm only going to be talking about a very narrow, very specific slice. We'll neck that down. But in terms of sort of how we got into this or what we're doing, part of a team, we've been doing this for the past 2.5 years, a couple of different projects. Talking about some of those. And so we kind of got started. Actually, this was my colleague, Andrea Brennan, was sort of asking these 3 questions about these systems, right? And she, fascinating, super smart lady. She comes at it from like a human interface and design perspective because she's a designer and an architect by background. So she's asking like these questions at a huge level. And she was putting together this project that she wanted to do in the coming year about doing this kind of work. And our leadership above us was like, that sounds super awesome. Do it now. You've got 2 months. Go. And so she roped me into it because for a long time, I've been going around telling anybody who will listen this thing where it's like, right now, AI and ML systems are the specific domain of very specialized, very highly educated practitioners, right? And there are very, very few organizations on Earth that can keep a team of, PhD level data scientists on staff to do maintenance and ops on these types of systems. And even if you had like the wealth of croesus that it would take to keep those people in those jobs, they're going to get bored and leave anyway, in my experience. Which is not like, first I want to clarify something. I'm going to make a bunch of broad statements in this talk about data scientists because I assume there aren't very many in the room. I'm not trying to rag on them. I'm just trying to be very candid about the fact that they have a very particular set of skills and they have a very particular set of incentives that are very different from the skills and incentives we have. And like, they need support from us to be able to do that. So I just want to be very clear about that so that I don't get yelled at later if I get angry data scientists. Like, you wouldn't roll up on the IT department and be like, hey, you guys are doing great with this computer thing. We need you to run payroll this month. No, you would get like, you would get sued out of existence. So in the same way that you wouldn't ask the IT department to do payroll, you shouldn't expect your data science team to be, operators or engineers. This stuff has to get moved over the fence, right? For people who can keep long-lived systems and keep them in check. So I've been saying that for ages, and Andrew was like, hey, you know how you're always talking about that? Well, we're doing a bunch of work around that, so time to put up or shut up. Which was awful, because then I had to do work. Yeah, I tried that. It didn't go well. It is indeed. So we started looking around trying to do this stuff. And one of the things that we came across was this document. It's the AI assurance, or the Artificial Intelligence Ethics Framework for the Intelligence Community. It's a fascinating document. You should take a few minutes and go read it. It's only 4 pages long. And it's one of those classic federal documents where they're like, yeah, we're going to give you this 4-page PDF where we knock out 17 or 20 questions that it's going to take you, this to answer, right? Like, you could murder forests trying to answer these questions and still not get there. But I pulled out sort of a couple of important quotes, and the The important one for the purposes of this talk is that second one. This is not a guide or checklist, right? Like, there's nothing in here that you can actually do to do this stuff. And so I start asking the question like, well, then what are we actually supposed to do? Yes. Well, yeah. You said it, not me. So, like, we basically set out to kind of like figure out how to do this stuff. And so I want to just kind of run through what they were really quickly so you guys understand what I talk about when I'm referring back to them later. Okay, so just bear with me. But the first one was the audit of the tool called Fake Finder. It was actually built by an internal team of data scientists. So it was a great first one to try because we had direct access to the people who built it. I could literally walk over there and be like, Mike, Felipe, what is this supposed to be doing? It's an open source tool. It's out there on GitHub. I think I've got the GitHub link down there. You can go find it. And what they had actually done was they had taken the top 5 performing models in one of Facebook's deepfake detection challenges. And they ensembled them together and they built a user interface around this thing. So basically it was a website you could go, you upload a video, it runs it through these 5 different models and it gives you the results of them with like your confidence scores and everything. Like I said, this was literally 2 people. We did this in 2 months. We had no budget whatsoever. So a huge driver in this work for us was just like, what can we do with no time and no money that's still useful? And you can see some of sort of the key lessons that we took away. One of the things that I thought was like super interesting about this in particular, one of the things that we found was, so if you go look at like the Kaggle competition that Facebook did, it was a deep fake detection challenge. When we started playing with the models, it's a face swap detection challenge. There's a bunch of them that actively crash if you give them a video without a human face in them, which is like, one of the things that we kind of really started thinking about, and this in particular goes back to Andrea, like I said, a design, interface person. She was like, this is a really poor job of communicating what this thing does to the user. They have no idea what to expect, because if you tell me this thing spots deepfakes, I'm going to think deepfakes of anything, but it's only looking for face swaps. That's not a useless tool, but you have to phrase that very differently to get useful, impact out of it. So that was the first one we did. The next one we did was Roberta, which is a large language model. It is one of the many, many, many forks of Google's BERT. In particular, we were working with Hugging Face's version of Roberta. And so the way those large language models get built, it's kind of fascinating in its own right, because they start off with a large language, or with a huge corpus of data, like tons of data, 100 languages, and they train these things very broadly. And then you go back and do a second training pass to narrow down what it can actually do. And so if you go look at like Hugging Faces repos, you'll see that they don't have just one Roberta model, right? It's like Roberta, and then there's this size quantifier, which is how much data it's been trained on. And then there's a sort of a task annotation, which is why I call out that we were specifically concerned with named entity recognition, because like if you go and read our stuff, we're always talking about, Hugging Face, Roberta, XL, NER. So just because I was literally just a second ago saying it's very important to be precise. So I would be a jackass if I didn't, narrow my own stuff down immediately afterwards. This one was kind of different from the first one because with Fake Finder, you've got a whole UI, right? There's deployment instructions, there's an established usage pattern and everything, right? A user's going to go in, they're going to upload a video, they're going to look at this chart that comes out and so forth. We didn't have any of that kind of context looking at Roberta, right? So we had to drastically rethink the way that we were doing these things in a lot of ways because we made that shift. So those are the first 2 we did. We actually have a third one ongoing now that has some stuff involving hardware, which is adding a new set of wrinkles to some of this stuff that hopefully I'll get the chance to talk to you about later. So I want to take a moment and just nod to like the bias, ethics, outcomes piece of this. That's a huge part of assurance in the sense that we've been doing it. It is massive. We worked with some folks at a law firm called B&H.AI. They're a bunch of lawyers that specialize in AI stuff. So those were fascinating and very expensive phone calls. But really sharp guys and really cool to talk to. And I'm not saying that stuff's not important, and you absolutely like should consider it and think about it. And like, you know, if you are dealing with one of these systems and you see something that gives you concerns in that vein, raise it. But that is not my specialty, and I would not presume to lecture people about that because not my place. So I just wanted to let you know that is like, particularly if you go look at, you know, the ODNI document I referenced earlier, there's like 3 questions about security, and the rest of it is all about this sort of thing. You know, I mean, someone's got to quantify how unethical the lawyers are being, and only a lawyer is specialized enough to know. So with that being said, what we're going to be talking about is the technical aspect of assurance. And that's, again, much narrower. It's one of those things that, at least when I started, it seemed very intimidating to me because I'm like, I don't know how you build AI. I don't know how to build ML models or, you know, training data. I took the 2 required statistics courses to get my degree and then noped right out of that. But the thing is, if you stop to think about it, like because I'm sure you've all heard like the same, you know, news articles and think pieces that I get all the time. Like, AI is this revolutionary new thing. It changes everything. It's going to eat the world. It's going to save us all. It's going to kill us all. Like, whatever you believe about it, everybody's like, no, it's totally way different than anything that came before. Which brings me to my next slide. This is the single most important slide in this presentation. It's not special. They didn't add a 2. Okay, it's still just zeros and ones. It's all just software and computers and networks. It's all the same stuff that you guys know and have to deal with. I know that sounds really dumb and obvious. I spent like a month grinding my wheels on stuff, and then I was like, wait a minute. This thing has an API. It's sitting on AWS. It's like, this is a web form. This is an Express.js server. This is Python. Like, I know these things. I don't understand what this big matrix of numbers over here is doing, but I actually don't have to. So again, as dumb as that sounds, that is the single most important thing. It's just software, and you guys already know how to deal with software. If you forget literally everything else I said, remember that, just software. So with that being said, you do have to do analysis of the models. When they build these things, you train them on data and you select that data. I like to think that AI actually stands for assumption intensifier, because that's really all it does. It takes the assumptions that you made when you picked your training data and lets you run those assumptions at internet scale. Congratulations, I guess. I don't know. But keep in mind that even if you can't see them, the assumptions that got made in selecting that data are now part of your stack and you're stuck with them. The other thing is, don't get crazy hung up on this stuff, right? Like, you want to enumerate the risks so you know what you're looking for and you know what problems you might have down the road, but you probably can't fix this model, right? This is probably not something that your team or anybody you have control over developed. So you just kind of like figure out what's in there and what it's doing, what it's supposed to be doing, and just know about that fact and sort of list it and document it, right? It's actually the smartest way that I found to treat these things is treat them like a black box library, right? Like, you went out and you bought some DLL somewhere and you can use it. Like, there's a bunch of, .NET controls or whatever in it. But you can't see what's going on inside of them. You just know, I feed it this input, I get this output, right? So, excuse me. Dependency analysis is really beneficial here because just to install these things, you need to know the dependencies. Keep track of them. The tuple of dependency and version is important because some of these things will be dependent on multiple versions of the same library because of the way they get built. It can get a little crazy. And you can have some interesting issues that arise out of trying to reconcile some of those differences. But that's important. And then the thing that I did to deal with the dependencies that I sort of found useful, because again, we want to get at the risks. We're not trying to say, oh, look, I can pop this system. Although if you can, that's great and it's super fun. I totally recommend it. But what I found to be helpful was to go through and kind of bucketize the dependencies, or sorry, not the dependencies, so once you've got those dependencies, you want to cross-reference them with your usual like vulnerability sources, exploit DB, the CVE databases, whatever you typically look at. And then you want to take those vulnerabilities that you found, and you will find some, I almost guarantee it. And you want to kind of dump them into three basic groups, right? These are unlikely or impossible, right? This middle group is plausible. And then these are the things that I think are likely, right? And what you kind of need to do is look at your execution paths and think through for instance, on the Fake Finder audit, I was looking at Pillow, and there was a vulnerability in one of the versions of Pillow, which is a Python image manipulation library. And to trigger that vulnerability, you had to be doing something with the alpha on the image, right? Like there was a particular function it had to pass through. And I knew based on the way we were using it, that it wasn't going to go through that function. So I've still got it in my list. It's plausible because it could be, still getting used somewhere else that I'm not necessarily seeing, but I didn't consider it likely because of the way our execution patterns ran. So thinking through it that way was immensely helpful to me. Fuzzing is another really handy technique here. So when we did the Roberta audit, I would literally use just like wfuzz and fuff, right? Like your normal fuzzing tools. The tricky bit with using regular fuzzing tools like that, or it's not tricky, but what's going to determine the effectiveness of those tools when you're dealing with a language model is basically like how clever you are at putting together your word list, right? Because if you think about it, I mean, that's what wfuzz does, right? Like you're running through a word list and just jamming it in as an input into something. So how you select that word list is going to be have a really strong impact on how effective that fuzzing actually is. The other thing to keep in mind when you start fuzzing particularly large language models is, as I said up front, those things get trained on 100 languages, 100 plus. I think it's like 112 in Roberta's case or something like that. If you only use the ASCII chunk of the table, you are not exercising things properly. You need Unicode. I had to write a big Python script that went like huge chunks of the Unicode table to build out word lists. But you can still get good output. You can actually get some pretty fascinating output. One of the things that we found, combining languages yields some fascinating things. So, and this was two of my colleagues, Ricardo Calix and JJ Ben Joseph. They've actually got a paper out about this. They found that there's this obscure Taiwanese dialect called Saesiat, I think. And there's this one very particular token, and the token is like a sub piece of language, okay? Like you can think of son is a good example of a token, right? So son can be a word in its own right, but it can also be like person, or it can be part of a name like Jefferson. Right? So it's this weird like symbol IE, the way it gets represented. But if you just add that onto a word, the way these language models treat it changes pretty drastically because it's a pretty rare token, because I think like 16,000 people in the world speak Saesiat or something like that. So it's things that are kind of at the either very low or very high end of your training sets have strange impacts sometimes. For computer vision stuff, we were working at with videos, but so the way those video models actually deal with anything, they don't look at videos. They break it down into frames, and then they run vision models on the still frames, right? So you can cheat and basically just generate big pixel arrays and get a similar fuzzing effect for those. Wrote a lot of Python scripts. Again, sort of the same caveat with the Unicode table applies, right? You think of pixels as being just sort of the RGB and what's this color. But remember, because of the way the models are looking at those things, they're breaking down into numbers. So you need to play with those other things like hue and alpha and saturation to, again, get full effectiveness from that. So, and then at the end, you got to put it together. Like this was the thing that I really thought was important that we do, right? Because if you look at the literature around security for AI and ML systems, people talk a lot about backdooring models and can we do model inversion, or can we ascertain the training data? And those are nifty, but they ignore the reality that these things are going to be jammed into a much larger system. And that system is what users and attackers are going to interact with, not necessarily the model itself, right? So you need to sort of reflect that in your testing. If it's the same thing as having a bunch of unit tests and no integration tests, right? You're still going to find some corner case that bites you in the ass because you tested all the pieces individually, but not the way they fit together. Source code analysis, if you're dealing with open source systems, and fortunately, at least I have had the luxury of dealing primarily with them, this has been incredibly fertile ground for me. SemGrep is one of my favorite tools. I run that in all our CI/CD pipelines. It's just using complex regex rules to find bad coding patterns. But the current hardware audit that we have ongoing, I've already broken part of that system. I have a working hack, and it's because I found something that was flagged by one of my SemGrep scans in our CI/CD pipeline. My boss foolishly bet me a steak dinner. So Whispers is another great one. That is looking for AWS keys, passwords, stuff like that. Again, those are things that even if you're just dealing with regular stuff, I highly recommend throwing those in your CI/CD pipeline because, debuggers, manual source code analysis, it has been big for me as well. When we did Fake Finder, okay, bear with me for a minute. This takes a bit to explain, but it's quite possibly my favorite hack that I've ever done, but it does require a bit of background. So the way that system was originally built was spectacularly expensive. It lived in AWS entirely. It consisted of 8 EC2 instances, a UI, an API, and 6 for the underlying models. An ECR registry to hold those model images, and an EFS file share holding the model weights. Okay, very important. I was looking at the source code and I noticed that when a user uploaded the video file, they saved it into the file system. Okay, this actually goes into my next slide a little bit, but they saved it into the file system, and they did so in the most naive way possible. They did not sanitize the input data at all. They assumed that whatever file name the user handed them for this model for this video was totally okay. And so this allowed me to start overwriting files in the system. And because it was being run with debug equals true, you look so sad. You have the same reaction that I did, but I won this one, so I'm able to look back and laugh. So it conveniently would restart things when I broke everything. I was able to insert an endpoint into the API that would accept base 64 encoded commands from me and do whatever I told it to. I was able to overwrite another file that was being passed via Bodo 3, which is the interaction point for AWS's API, that they were using to spin up new machines. This file was being passed in as a startup script. By the time it was over, so the script that I wrote to attack this whole system, it took about 30 minutes or so to run. By the time this attack was done running, I had taken 7 of those 8 EC2 instances over and enrolled them in my C2 server. I had poisoned all of the images in their ECR, okay, with exact copies of those instances that did the exact same thing they were supposed to, except that when they came up, they also enrolled themselves in my C2 server. So even if they blew it away and just pulled their images back down, guess what? I'm still in charge. I had poisoned the weights on the EFS file share. The only thing I didn't have control over was the actual UI server, and I was literally sitting there going, I don't care at this point. I own everything else down the chain. I showed the best part of it was I showed our IT department, the guys who were in charge of like our AWS instances, what I had done. And I was like, I made them sit there while the script ran, like with the output and everything. And the head of the group that's responsible for the AWS stuff looked at me and was like, so you're more like chaotic evil or neutral evil? I'm just, for our records, we need to know. But it was so fun to watch them. So again, the normal tools that you use for API testing are incredibly useful here. And like I said, don't just think about the model, those interstitial bits, right? Are they saving stuff to the file system? Are they putting stuff in a database? Like, those are things that you can target, that you can pivot on, that you can leak information from. So consider those carefully as well when you're looking at the architecture of these things. Man, it was such a fun hack, though. And then again, application testing. And I feel like I keep saying this over and over again. This is very similar to the way you approach this in normal application testing, right? What are the component pieces? How do they talk to each other? What are the data types that flow between them? The entity relationships? I mean, the same sorts of like mapping tools and things that you normally use, again, come in really handy here. They, again, it's still just software testing. You just have to keep a couple of weird little tweaks in mind to sort of get the most out of what you're trying to do. But again, like this is all things that people who do this for a living are capable of. It's just, we tend to think that this is a different thing. One thing that is kind of different that I do want to take a minute to talk about is the development environments for these things. IPython is the big one, and that is the construct that sits underneath of both Collab and Jupyter Notebook. Those environments are frightening to me as a security person because I would like to know the person who made the command decision. It's like, what we're going to do is we're going to stand up a little web server on your computer, but we're going to give it a bunch of permissions. We're going to let it execute arbitrary Python and JavaScript code with weird data files, and we'll give it like user access to the system. I don't, like, who greenlit that? But that's how those things have to work, right? Like, if you go look at an IPYNB file, which is the file format that these things spit out, it's actually a JSON file that has HTML, Python, and JavaScript and raw text jumbled up together inside of it. So when we started, when we started, there was actually a thing going around. It was a worm that was going around. It was being passed through Jupyter Notebooks, and that started me getting interested in that sort of thing. And I started kind of like digging into it and seeing. I am going to take a moment and toot my own horn. I found 2 CVEs in Jupyter Notebook. Technically, it was the same one. They had implemented the exact same mistake twice in 2 different places. But if you go look at the database, it's 2 entries, so I'm claiming it as 2 wins. Long story short, they're, like I said, these things have access to the file system as the user that started it up. And so it gives you this nice little tree view of the file system off to the left side, right? Like here's your directory structure, here's everything, all the files you can interact with. The API underneath of that wasn't respecting settings about hidden files. And so if you knew where a file was that was either hidden itself or in a hidden folder, and you went and asked the API for it, it would just cough it up and hand it over to you, which was super great because like I literally went through, and a bunch of the data scientists I work with, I stood over their shoulder. I was like, start Jupyter Notebook for me. That's all I asked them to do. And they all did the exact same thing. They pulled up a terminal. It's sitting there, tilde, their home folder, right? Jupyter Notebook. Started. Like, okay, cool. You've answered my question. Because that means now I can dump right .ssh ID _ RSA. I've got their creds. I can move across it. Right? I wrote a fun POC for this that modified the .bash RC file. So when you started a new session, it would just start sending commands and such back to me. That was a fun one. Another thing I noticed is when you start it by default, it's token author. It uses something called token authentication, right? So it creates a randomized user token. So this is a bit of a chicken and egg, but this is actually how I first found it. So it's kind of interesting, at least to me. I was trying to exploit this XSS vulnerability that existed. And I found out that it wasn't properly hiding hidden files. And so I realized I could probably dig out the file that had the token in it. So theoretically, like, okay, in theory, you already have to be authenticated to be able to do that. But the other possibility there is that somebody's running a compromised browser, because how many people are doing that, right? Nobody. So yeah, there was a way to get out that token, or that same hidden file in the home directory has the something notebooks.db. It's literally like the root trust file the Jupyter Notebook and Jupyter Server use to decide which cells are trusted, which trusted here meaning can be run without user interaction. So if you start monkeying with that, and it's tricky to do because there's a complicated signature algorithm that has to match up for it to think that the thing is. So it's not trivial, but you could, in theory, monkey with that trust situation. I was never able to get it actually working properly, but maybe somebody smarter than me could. So based on that, like managing this stuff, major recommendations. There's an allow root bit. Do not let them use that. Stop that. That's the first one. And the reason you'll usually see that is if they're running it in a Docker container, instead of structuring their Docker container with the proper permissions to run as a different user, they'll just go, oh, we'll just set allow root equal true. Well, no, because particularly if that's a privileged container, now I'm just out on your hardware. That's actually one of the other things I found that's going on in the hardware audit. There's one of these with allow root and a privileged container sitting next to it. So that's my current project, is getting from that one to that one. Don't put it in system like sensitive places, right? Home directories, no. I saw one somebody were put it in the file root, and I was like, God, why would you do this? So wall those off. Put make C/notebooks or something like that. Something where it's just that, because I will give the Jupyter folks credit. It won't let you traverse above what the notebook directory is set at. So as long as you just narrow that down, that's very good. And then, I think that's, the IP addresses. By default, it only wants to listen on the loopback. Again, people being lazy will set it to 0.0.0 because I just want it to listen to everything. Your facial expressions mirror my day to day. I feel like you and I must work with similar people. It really is. It's my thinking is, and I've seen this sort of in a couple of things that I've done over the past few years, because I also did some work on some 5G stuff with Open 5GS. And I think what's happened in a lot of ways is that people who previously didn't do software for various reasons, right? Statisticians didn't really do software 10 years ago. RF people didn't really do software 10 years ago, but now, data science has brought statisticians into software. Software-defined radio has brought RF people into software, and they're making a lot of the same mistakes and errors that we as software people made back in like the late 90s and early 2000s when we were all like you guys look like you're old enough to remember back in the day when we'd be like, oh, we'll just put it behind the firewall and then it's fine, right? They're redoing all the same dumb crap that we did back then. Which again, going back to my earlier point, like they shouldn't have to be experts. We are the experts in this thing. We should be the ones supporting them and going, hey, you can't do this like this. Here's how you make it better, right? Updating on these things gets interesting though. Yeah, it gets ugly is actually what it gets. Because they tend to end up super hard locked to one or two of typically those 6 libraries. There's some other ones, but those 6 are the big ones. And because those 6 tend to be tightly coupled to things like CUDA drivers, kernel versions, all sorts of things, it becomes a mess when you try to update them. And you have to manage it carefully. And the other thing you have to realize is that I talked a lot about the Fake Finder audit. When that was over, they were like, you found all this stuff and this stuff is really terrible and that's great. I'm like, yes, that's. And then they were like, now fix it. I was like, oh, God, man. So that was like the next 6 weeks of my life, and it was not fun. But we got it fixed. And one of the things that I did was I realized that you didn't actually need EC2 instances for each model, right? Like they were all using the same API factory pattern to talk. So it's like you can add just one more parameter telling it which model you want, and you'll get the exact same behavior. And so I said it was crazy expensive to run. I meant it. This thing literally costs like $900 a month just sitting in AWS, not doing anything, just $900 just to exist. When we got rid of a bunch of those big GPU enabled instances that were mostly sitting there doing nothing, we got it down to like 30, 40 bucks a month, which was a huge win, in my opinion. And most people's opinion, because, that's 760 some odd dollars, right? Whatever. One of the things that I did was I had to bring all these different models down to have the same set of dependencies so that I can install them in the container where they're going to be run. And what I found was that actually changed some of the outputs. Not like hugely, but when you're talking about probabilistic data, right, like probabilistic outputs, you get these changes in the probabilities, right? It's not like you run normal unit tests. It's like, okay, this added 2 and 2 and it got 4. Check, it passes, right? This is like this is approximating adding 2 and 2, and it thinks that there's a 97% chance that it's 4, but now when we update it, it's a 92% chance. And so the thing that I started really thinking about there was, again, I said all these models were winners of a Kaggle competition. That's important because they're trying to win a contest, right? Like they are focused like a laser beam on that F1 score. Like that is their dark and terrible god, right? Your F1 score is too low. You don't get to be Archduke of Nurips. No prizes for you. But if you're me and you've got to run this thing in production, you'll probably take a 0.5% drop in your F1 score to get rid of, 3 vulnerabilities, right? Like, so some of these things become an interesting set of engineering trade-offs where you start having to say like, okay, if we update this, we're going to have to change these other things, and here are the impacts on our performance. So you have to be very careful to not be dogmatic on either side of this, right? And again, some of these things just age very poorly. Like I'm dealing with one that was written 2 years ago right now, and it's really tough just trying to get it to run now the way it's supposed to. But unit tests and integration tests are important. Like I said, just don't get dogmatic about it. Be willing to have those engineering conversations, right? Like this is, I think, a good meeting point. So, like I said, just to kind of wrap things up, you guys probably, like, I haven't told you anything revolutionary. You guys already all know how to kind of do this stuff. But hopefully I've kind of like demystified it a little and made it seem a little more approachable and like something you can tackle in your own environments. And, like I say, I want to take a minute and thank some people. I've got to thank Andrea who brought me into this work. I really appreciate that. And my other colleagues who have been really fantastic while I've basically spent like 2 years just breaking their toys, like nonstop. They're like, look at this thing we built. And they're just like, but they've been super great about it. Very supportive. So, the conference organizers for letting me come up here and you guys for listening to me. So really appreciate it. And my wife putting up with my crap. She came out to listen to me, even though she probably could have done that at home for free, although frequently would opt not to if given the choice. And with that being said, if anybody has any questions, got to stop. Yeah, so lots of really ugly Python is the short answer to that. Like really, really ugly Python. So we did a couple of different things. We used, they were doing a bunch of experiments using something called protagonist tagger, which is this big corpus of data that they've basically taken a bunch of different novels and, people have gone through and done this annotation process, which I don't entirely understand, but they say, like this is a person, this place is a thing, this kind of thing. Novels and things like that are great sources for word lists. As dumb as it sounds, Wikipedia, like anything with a bunch of text and a readily available API that you can scrape, or you can use Beautiful Soup and start scraping web pages. That's really helpful if you are, you're concerned with like particular languages, right? Maybe you're worried about like East Asian languages or Middle Eastern languages. You can start, setting locale strings for various places and digging things up that way. That's probably the best advice I can give you with that. I appreciate it. Yeah. Well, like I said, there's been a whole group of people that's, engaged in like the broader, the broader assurance concept that, like, I go talk to them and stuff, but they're the experts on that, not me. But that's been sort of fascinating in its own right. Like, I remember sitting in a meeting and we were kind of breaking things out along like federally protected classes, right? Because of who we work with, that's sort of what we cared about, and that's like an actionable metric, right? Like, that's the other thing. A lot of this stuff is still particularly legally really hazy. There aren't any rules, so we're borrowing stuff from like, finance and fair housing and fair lending standards and things like that, and kind of trying to like cobble some of that stuff together. And what I found kind of fascinating was like there was this whole very academic discussion at one point about why we picked, federally protected classes versus this, I can't remember the name of it, but it's like this basic tone scale that you can use as well. And we're like, well, this is why we've done this, but we had to go through and justify it, things like that. So it's been a fascinating topic area to work in. And like I said, we're doing a bunch of, Sure.
So, my clients in this space, like, they love the idea of patching all this stuff, but because everything is so built on top of this thing, on top of that thing, patching some disparate components is really
Mm-hmm.
I'm glad you mentioned that, like, the default readings of things can, you get, like, different approximation values and stuff. Like, how do you, the the best I've been able to do, and I'm not happy with it, is I'll have different APIs available. Here's the OG API, here's version 1.1, version 1.2, on infinitum. Like, what's the best path? Or is there? Like, what's the way to make it suck less?
It hurts a lot. So one thing I've done in sort of one of my own things is I'm a maintainer of an open source project called Network ML. It was a fascinating thing in its own right. We wanted to see if we could use machine learning to make determinations about network traffic based purely on headers. Total sidebar. But yeah, it's on GitHub. You can go check it out. Happy to give you the link. But I literally have basically kept the data that I used to originally train it around in like a compressed form. And I have to retrain when I update these, some of these key libraries. I just, and that's probably like the best thing that I've come up with is if you can implement some mechanisms to sort of short circuit your training process so that you can rerun it with updated dependencies. And then again, make sure like I basically have a loop where I rerun the training and I check that I'm within like plus or minus 5% of where I was the last few times. And that's kind of, now it's worth noting that's an open source project. I don't run production systems. So things may be very different from your client, right? Like a 5% difference in outcomes may seem like nothing to me, but may be critical to them. But there's not a great way to handle that. I mean, I think the ultimate thing is like some of that stuff needs to be regression tested more before they put it out. But I also, like if you've ever tried to interface with CUDA, you know what a nightmare doing anything with that is too.
What's your thoughts about doing things like having individual computers that you very tightly control the network outside?
That's something that we do a lot. So what we'll do is we'll build our container images. We'll build like base images basically, right? Build a base image, grab the hash of the base image, and then pin your Docker file to that hash for a base, run from there. Pinning your dependencies, also very important here because again, you need like the repeatable builds become. But yeah, that's definitely. And the other thing too is if you have the ability, right, being able to stand up your own private registry and use that as opposed to having to go and grab whatever is on, Docker Hub or what have you, that can also help with that repeatability problem quite a bit. But it is a huge pain in the ass to run your own registry. So, well, okay, yes, tedious. There is that. Thank you guys. I appreciate it.
This talk was a part of our 2022 Secure West Virginia Lucky 13 conference. If you would like more information about this talk or our speaker, check the description below. And if you enjoyed the content, consider liking and sharing this video. For more information on Secure West Virginia or you want to stay updated with the latest upcoming events, follow us on Twitter at SecureWVCon or visit our website securewv.org. We would also like to thank our 2022 sponsors for being a huge part of Lucky 13's success.